Recording in progress.
So this is the lesson for Monday. We're gonna, in Math 7, we're gonna start section 4.3, which starts off on page 155. The bell ringer for this morning is actually gonna just be a review of the previous section, especially with it being Monday. So I would like for you to find the greatest common factor using the given method. So we're gonna practice all of them. All right, so for number 1, I want you to find 12 and 18, and this is not in your book, so you don't have to go looking for it. Using listing factors. So you just list all the factors and then because they're small enough, you should be able to do it in your head. List prime factors and then figure out what's common. Okay, and then second one, we'll work through these together in a second, is 60 and 102 using the factor tree. And 3, I can get this to all fit, 39 and 36 and 90 using the factor ladder. All right. So listing factors, this kind of goes back to the first part before we even work too much with prime numbers. So you're just listing all of the factors of 12 and 18, and then you're just telling me which one is the highest. So these don't have to be prime numbers. So what are the factors of 12? We have 1, 2, 3, 4, 6, and 12. Yeah. So 1 times 12, 6 times 2, 3 times 4, those are our factors of 12. All right, what about for 18? We know 1 goes into it, 2, 3, right? 4 doesn't go into it, 5 doesn't go into it, 6 goes into it. And so we've reached the middle, right? 3 times 6 equals 18. So now all we have to do is go to 2. 2 times what equals 18? That's for 9. And then 1 times 18. All right, so looking at this list, what's the greatest common factor of 12 and 18? So which one's the biggest? 6, yeah. Greatest common factor. So the greatest common factor of 12 and 18 is 6. Yep. We don't use this that often. It's just kind of a review of what we're doing. Well, right. And so when I asked you to do this, I gave you how I wanted you to look for the list. We're practicing all 3. The first one, we're practicing listing factors, which is, that one's not efficient for the most part. So we don't use that, but it's just kind of a reminder of what we're talking about here. For number 2, I wanted you to use specifically a factor tree. So for 60, what would that break down into? You can do it multiple ways. I love multiples of 10. I just break it down to something times 10. So 6, I'm going to do 6 and 10. You're going to end up with the same answer no matter what you do. So 6 breaks down into 2 and 3, and 10 breaks down into 2 and 5. So 60 should get 2 squared times 3 times 5. All right, I'm going to just do this from here. 102. So 2 and 51. So I know 2 is a prime number. So let's break down 51. I know 5 times 1 is 6. So what number goes into it? 3. So 3 goes into 5 once with 2 left over, and 3 goes into 21/17. So all those look like prime numbers to me, yes? So 102 is 2 squared times 3 times 7, or no, sorry, not 2 squared, just 2. 2 times 3 times 7. So what common factors do I have between these two? Right, I have a 2 and I have a 3. Then once I write all the factors that exist in all the numbers I'm comparing, in this case 60 and 102, then I look at which one has the smallest exponent. In this case, the 2 has an exponent of 1, understood 1, and the 3 has an exponent of 1. So what's the greatest common factor? Which is? Gives us 6, exactly. So the greatest common factor of 60, goodness gracious, is 6. All right, so for the last one, they want us to do the factor ladder. So if I'm comparing two numbers and I'm doing a factor ladder, I'm going to do the combined ladder. So I'm going to write 36 and 90. And again, when we do the factor ladder, what do we start with? The smallest prime number that, yeah, which in this case is 2. 2 goes into 36. See, it goes into, I think it's 18. 2 goes into 3 one time with 1 left over, and 16 is, yep, so 18, and 2 goes into 90. 45. Sure. Go ahead, just don't look. Yes, I know, you got it. Excuse me. Okay, now 18 and 45. Does 2 go into both of these numbers? No. So then we have to go to our next prime number. It's 3, and 3 does go into both of these numbers. So 3 goes into 18 6 times. It goes into 45, not 9 times. Hold on, let me think. 15? Yeah. All right. Are there any more prime factors of 6 and 15? We have 3 again. 3 goes into 6 2 times. 3 goes into 15 5 times. All right. Now, do we have any more common prime factors? So that means that this entire list on the left-hand side, go ahead, is our greatest common factor. Which is 18. There we go. Good job. So that's 2 times 9, which is 18. So 18 is the greatest common factor. So you doing like a double factor, like a a double ladder or a combined ladder like this does make sense. I like that a lot more than just doing like one ladder at a time, for sure, because then we look at both numbers together. Okay. Now let's move into section 4.3, which covers least common multiple. All right. All right, so some things that you should understand by the time we're done here is how to find the least common multiple of 2 or 3 numbers, and then how to use the least common multiple to solve real world problems. So we'll learn some word problems. All right, so let's look at the example that they give us at the very beginning on page 155. So it says, Victoria likes to maintain a regular schedule to accomplish her chores. Imagine that. She waters her indoor plants every 10 days, vacuums her floors every 4 days, and shops for groceries every 5 days. How often will all 3 tasks fall on the same day? Well, to answer this question, Victoria can list the multiples of 4, 5, and 10 to find the common multiple. Right, so you can see that from the list. So this is like a real, so this is, remember, let me go back to this really quick. So remember when we talk about greatest common factor and least common multiple, what operation are we talking about? What operation contains factors? Addition, subtraction, multiplication, or division? Factors? a factor, I tell you a factor and a factor equals a product. What are we doing with greatest common factor? What are we doing with those numbers? We're multiplying them. So we multiply factors to get a product. So in this case, you can think of product as multiple. So a factor times a factor equals a multiple. So when we are looking for greatest common factor, we're looking for the largest number that you can multiply times another number to get your answer, to get your original number with greatest common factor, right? Because we're looking at the largest number that can divide equally into the given number. With multiple, we're looking for the least common multiple. So we're looking for the smallest multiple that all factors divide into. So remember, when you add or subtract fractions, you have to find a common denominator. You're finding the smallest common denominator. So you're finding the least common multiple of the denominators in your fraction. So this is least common multiple. This is exactly the same thing. So let's go back into the problem that we had. So in this case, she has her chores. She knows that the chores, let's see, vacuuming happens every 4 days. So she needs multiples of 4. And so we look at days in the schedule. You don't necessarily have to write this down. So she all right, so multiples of 4. Groceries, she goes shopping every 5 days. So these are multiples of 5. And the watering she does every 10 days. All right, so when I find least common multiple, one of the best practices that I teach my younger students when they're working with fractions and finding that common denominator is to start with the biggest number and create multiples. So in the case of this, the biggest number is the 10. So I know multiples of 10. 10 times 1 is 10. 10 times 2 is 20. Go ahead, I'll just keep making my video. 10 times 2 is 20. Well, I know that 4 and 5 go into 20, but I'm just going to go ahead and show you the multiples anyway. 5 times 1 is 5. 5 times 2 is 10. So this one has a smaller one, but we got to make sure it works for all 3. 5 times 3 is 15, and 5 times 4 is 20. So again, there's my common multiple. With 4, I have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and then there's my common multiple, 20, 4 times 5. All right, so once I have that, then I find that the smallest common multiple between 4, 5, and 10 is 20. So that means that every 20th day, she will do all 3 on the same day. All right. So I'll be watching out, making sure there's nothing else I need to do on those every 20th day. All right, so let's go to the book's definition of your least common multiple. So the LCM, or least common multiple, is the smallest. My pen stopped working. Hold on.
Recording in progress.
So, sorry, let me catch myself up here. The least common multiple is the smallest positive common multiple of the given numbers. I'm also going to say product, right? Because product is the name that you've learned every year so far of the solution to a multiplication problem. So the smallest positive common multiple of the given numbers. All right, so there's our definition that we need to make sure that we're staying up on. Okay, so let's look at an example of this. So finding the least common multiple using lists. So again, this is kind of the basic part. The 9 and 12. So remember, we're not breaking these numbers down into factors, smaller numbers to find the largest smaller number, the largest factor. Instead, we are multiplying these numbers times other whole numbers, finding their multiples in order to look for some commonality between them. So we're just on example 1. You can write, well, you don't really need the definition. Just start where I am on example 1. Promise. The other stuff, like I said, that was just an example to follow along with. All right, so the first one, what are the multiples of 9? So 9 times what equals 3? All right, so multiples of 9 are all the numbers that 9 goes into. So 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. And 9 times 5 is 45. So we'll start there, see if we end up with anything. So multiples of 12. That's multiplication. So 12 times 1 is 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. 12 times 5, 60. I'm just going to go include all of them. But what's the common multiple of these two numbers? Well, it's 36. Okay, so by listing multiples, we can see that the smallest number that 9 and 12 go into is 36. They also go into 72, but is that smaller than 36? No. So there are always multiples of both numbers that are common, but we want the absolute smallest. Okay, that's the only example I'm going to do because we're not going to use listing to find common multiples. We want to use prime factorization to find our least common multiples. So let's use the same example, but using prime factorization so that you can see a comparison of the two. So again, I'm going to find the multiples of 9 and 12, but I'm going to use prime factorization. So in this case, because 9 and 12, let's see, we want multiple. Yeah. Okay, let's do this. You don't want to use, I don't think we're going to use the combined. Well, you might be able to use the combined ladder. We'll get to that in a second. First, let's do the tree. I like the tree. Okay, so break down 9 into its prime. We're gonna do. Sorry, you look like you have a question. Gotcha. All right, so if I break down 9 into its prime factorization, that's 3 times 3. And if I break down 12, I get 3 times 4, which breaks down into 2 times 2. So let's write them out. 9 equals 3 times 3. That's its prime factorization. 12 equals 2 squared times, oh, I did it that way. That's 3 cubed. This is 2 squared times 3. All right, so let me go ahead and let me write our steps too. So step 1, complete the prime factorization of the given numbers. All right, that's what we have here. Our second step is to list all given prime factors. So you'll notice I'm not asking for all common prime factors. I'm asking for all given prime factors. So again, let's look at our example here. So between 9 and 12, what are all given prime factors? 2 and 3. Now, with least common multiple, even though the 2 is only in 12, we still include it because we must have a number that both 2 and 3 go into in order for 9 and 12 to go into it, to be factors of it. All right. The second part of this, but it's going to kind of be together here. So I'm sorry, the third part of this is use the prime factor with the highest exponent. So again, it's the opposite. Multiple, you're looking for a number bigger than the given numbers, equal to or larger. With greatest common factor, you look for it could possibly be equal to the smallest or smaller, right? Factors equal multiples, but the given numbers are factors of the least common multiple. So we use the highest exponent. So for 2, what's the highest exponent in our prime factorizations? It's the 2 squared. With the 3, it's also squared, right? So 3, an exponent of 3 is cubed. An exponent of 2 is squared. All right, so that means what's 2 squared? 4. 3 squared, 9, and that equals? Right, which should be our answer, right? Because when we make a list of multiples, we got 36. I'm showing you how we do this with prime factorization. Now, if you have numbers like 9 and 12 that are part of the multiplication tables you've been memorizing since, what, 2nd, maybe 3rd grade, then you probably could figure that out in your head. And that's where the best practice I've given students is start with the highest, right? So we start with 12. 12 times 1 is 12, 9 doesn't go into 12. 12 times 2 is 24, 9 doesn't go into 24. 12 times 3 is 36. Oh, 9 does go into 36. So those you can do in your head. This example, we already know what our answer is going to be. So, you know, it's a nice to use to an example to learn the process because you already know what your answer is going to be. All right, so I want you to work on skill check B, and let's see how we do. So number 1 is actually exactly what we did for the example. So I went ahead and just finished it. Again, but using your steps, you take with the least common multiple, you take all given factors. In this case, we have the number 2 and we have the number 3. And then you go back and look at the highest exponent. 2, the highest exponent is squared. 3, the highest exponent is squared. So that's where we got our 4 times 9, which is 36. Okay. For 21 and 28, the least common multiple, we take all prime factors between the 2 given numbers. We know that there's a 2, there's a 3, and there's a 7. You only write it once, just once, like the 7, just because there's 7 and 21 and the 7 and 28 doesn't mean I include 2 7s. Then you go back and look, which ones have a high exponent? Well, 2 is the only one that has an exponent given. So we know the others are the understood 1. So the least, and then you just simplify. So this is 4 times 3 times 7, which is 12 times 7, which means that the least common multiple of 21 and 28 is 84. All right, and then number 3, the least common multiple of these 3 numbers. Again, we do the same thing. In 20, I have a 2 and a 5. In 30, I have a 2, a 3, and a 5. And then in 40, I have a 2 and a 5. So I know that my prime factors are 2, 3, and 5. So then I go back and I compare all of my 2's. Which 2 has the highest exponent? Cubed. Right, 2 cubed. What about the 3? There's only 1. It has no exponent, so I keep the 3. And what about the 5? They're all just 1, so we leave it. All right, so now we simplify. What's 2 cubed? 2 times 2 is 4, times 2 is 8. So this is 8 times 3 times 5. So I'm actually going to combine my 3 and my 5. So this is 8 times 15. And 8 times 5 is 40. Carry my 4. 8 plus 4 is 12. So the least common multiple of 20, 30, and 40 is 120. Which makes sense, right? Because the least common multiple of 2, 3, and 4 is 12. Tacking a 0 on the end. Oh, what you got? All right, so there's the least common multiple of the 3 numbers. So for 4 and 5, they've asked you to actually do the prime factorization. So let's go ahead and finish that. I know that 40 is 4 times 10. This is 2 times 2 and 2 times 5. So 40, I've got 2 cubed times 5. I'm actually going to write that over here so I don't take up so much room. All right, and then 100. Okay. So you got 2 squared, 5 squared? So 100 is 2 squared, 5 squared. All right, so least common multiple. What are all the given prime factors in these 2 numbers? We have a 2 and we have a 5. Well, what's the highest exponent of all of the 2's? Cubed. And the 5? 5 squared. Right. So it's 8 times 25, right? Because that's 2 times 2 times 2 is 8. 5 squared is 5 times 5, which is 25. So I'm gonna 25 times 8, carry my 4, and so that is 200. All right, so the least common multiple of 40 and 100 is 200. Making sense? Okay, so we'll do it again. 60. I'm gonna, again, I like to break it down into 10. So that's 2 and 5. 6 breaks down into 2 and 3. So 60 equals 2 squared times 3 times 5. Done like 3 times, I feel like. Anyway, we'll keep going. All right, and then so 75. 5 goes into 7 once. So 15, 5 and 15. And then 15 breaks down into 3 and 5. And so we have 3 times 5 squared. What you got? Okay. So least common multiple. So not all even on the line. All right. So write down all your prime factors. We have a 2, we have a 3, and we have a 5. Now for 2, what's the highest exponent? Squared. 3 is just 3, both of them. And 5 is squared. So Right, so 4 times 3 is 12. Yeah, this one's gonna be. I know, I think it's what, 300? Because 25 times 10 is 250 plus 50, which is 25 times 5. So it should be 300, but we'll do the math. So carry my 1, that makes that a 5. Yep, it's 300. So it's 250 plus 50, so 300. So least common multiple is 300. If I can get it right. Because 300 is the smallest number. It's 60 times something. 75 times something equals. Right, like 75 times 4 equals 300. 60 times 5 equals 300. So 300 is the smallest number that is a product of 60 and 75 times some other whole number.
So you can do some least common multiple equations like mentally,
Absolutely.
like 5 and 2.
Right. Like 4 and 5. A lot of times the numbers time themselves give you the least common multiple, like 4 and 5. Those are any relatively prime numbers. You have to multiply times themselves to get your least common multiple. All right. I'm gonna go ahead and give you the homework assignment. Because I feel like you can use well, let's save on the factor ladder. Let's see here. 2. Go ahead and, well, I think you'll probably be able to get the factor ladder. 2 through 24 even. So these are on pages 158 and 159. Numbers 2 through 24 even. Give those a try. You do have one using the factor ladder, which technically we haven't gotten to that example yet, but I think it's only one. I think you'll figure it out. All right, so that concludes today's lesson. We will review this and then maybe start the quiz review tomorrow. We'll just sort of play it by ear. We'll see who's here and how far we get. All right, thank you.